Good day, students. Welcome to math.serve.com. In this short presentation, we're going to be going over the mechanics of the computations governing the connection between position, velocity, and acceleration. Okay, so this is a task. You're to find the following and state their meanings with the correct units. For the problems we're going to be going over, the distance will be measured in meters and time will be measured in seconds. Okay, so for number one, we have the function x of t equals 2 sine t. So that's a function we have to find v of pi and a of pi. All right. So first thing I want to go over is the connection between x, v, and a, position, velocity, and acceleration. So you have x, v, a. X as a function of time is the position. V is the velocity. And a is acceleration. All right. So what's the connection here? First of all, you have to keep in mind the fact that this is the order that they go in, okay? Now, when you're going down the continuum, what you're doing is you're differentiating. So going down, you're going to be differentiating with respect to time. If you differentiate x position with respect to time once, you get velocity. When you differentiate velocity once with respect to time, you get acceleration, okay? So let's write down some equations. The derivative of position with respect to time is your velocity, xv. The derivative of velocity with respect to time is your acceleration, okay? And if you want to connect position and acceleration, the second derivative of the position is equal to acceleration. In that case, you're differentiating position twice and you're skipping straight ahead to acceleration. All right, so let's go ahead and solve the problem. So we asked to find v of pi. So to find v of pi, there are two steps, okay? So let's write them down. Steps number one, you are to find the velocity function first. And then secondly, you're to evaluate the velocity function at the specified time, namely pi, okay? Now you always want to remember calculus goes before arithmetic. You do the calculus first and then arithmetic, okay? So we're given the position function x of t, which is equal to 2 sine t. Now how do you get the velocity from the position function? You differentiate. You can write it as d dt, but I'll use the Lagrange notation prime. So x prime of t is equal to, factor out the 2 times the derivative of sine t. Okay? Now what is the derivative of sine t? The derivative of sine t is positive cosine t. Okay? So x prime of t is the same thing as the velocity. So we can write this as x prime of t, which is also equal to v of t. So v of t is equal to 2 cosine t. Now let's figure out what the velocity is at t equals pi. So we're in step 2 now. We just did 1, which is to differentiate. Now the second part is to evaluate. Okay, we're doing the arithmetic process. So v of pi is going to be what? It's going to be 2 cosine pi. Okay, so what is cosine pi? We can refresh our memories by sketching the cosine function on the necessary domain. So we're going to go your cosine function. Let me try and make it as nice as possible. So your cosine function is like the cups, starting from 1, and then it goes down like that. Okay, so there goes your cosine function. All right, but we're looking for cosine of pi. Pi is right here at the center. So when you trace pi to the function, it takes you to the minimum of the cosine function, which is -1. Okay, so v of pi is 2 times -1, which is -2. Now, what is the unit? The unit for velocity is distance per time, so it's going to be meters per, what was our time unit? Time was to be measured in, let's see, time is measured in seconds. So it's meters per second. That's what our time is going to be, meters per second. Okay, let's take a look at the meaning. V of pi equals -2m per s means that the velocity at t equals pi is equal to -2 meters. Okay, that's right. Is -2 meters per second. Okay, so that's the meaning of this result that we got right here. Okay, let's advance to the second part. We have to find a of pi. So we're going to find a of pi. Okay, now just like v of pi, we have two components here, two parts of the steps. Okay, so for the steps, the first part would be to find the acceleration function. That's the calculus process. And then we're going to evaluate it at the specified time. This is the arithmetic component. So don't forget, calculus comes before arithmetic when you're evaluating derivatives at specified input values, okay? So we know what the velocity function is. V of t is equal to, what is V of t? 2 cosine t. So what's the acceleration? The acceleration, remember your continuum, xva, when you differentiate velocity once, you get acceleration. When you differentiate position twice, you get acceleration. Okay, so there are two ways you can go about it. I'm going to differentiate velocity since we've already done the first step, which is differentiating position. Okay, so acceleration, a of t, is equal to the derivative of velocity. Okay, so what we're going to do is differentiate 2 cosine t, 2 cosine t prime. Now, what is the derivative here? We're going to use a constant multiple rule, factor out the 2, and focus on differentiating cosine t. The derivative of cosine is negative sine. Okay, so our acceleration function at any time t is given by -2 sine t. Okay, now we're done with the first part, which is to find the derivative using calculus. Now the second part is to evaluate. Okay, so part 2, we're going to evaluate a of pi. So a of pi is what you get when you plug in pi into your acceleration function, sine pi. Okay, so what is sine of pi? Let's refresh our memories by consulting the sine function. So if you want to sketch a sine function, remember what the sine function looks like. So it's kind of like an S. So you have one complete cycle of your sine function looking like this. This doesn't look good, but it's okay. So this is pi right at the center. So what is sine of pi? Sine of pi is the output for this input value. So your output is 0. So it's going to be 0. So a of pi is -2 times sine of pi, which is 0. Okay? So when you compute this product, your final answer, a of pi, is going to be 0. Okay, and then the units for acceleration is meters square per time, which is, I got it reversed, is distance per time square. So it's going to be meters per second square. So acceleration is meters per second square. Okay, what's the meaning? The meaning of a of pi equals 0 is the acceleration. The acceleration at t equals pi is 0 meters per second square. That is the meaning of the results that we got right here. Okay, so that's that.